Alright guys, today's lesson is on domain and range, which is something you should be somewhat familiar with already. We'll review real quickly though. Domain is all the x values, so it's your x values for any given list of coordinates or graph or function that you have. In this case, remember x first and then y in any coordinate pair. So we would just list out all the x values for these 5 points. So the domain here would be 1, 3, -2, 6, and -5. The range is all the y values. So in this case, we do is list the y values, starting with 4. Next one is 6, 7, 0, and 8. And if you happen to have the same y written twice, like if you had 2 4s, you only need to list it once. So if you have doubles, don't write them twice, just write them one time. But that's all there is to it. Domain is the x's, range is the y's. However, on a graph like this, where we have a function that's continuous, there's actually an infinite number of x values. It's not just 5 points. There's an infinite number of points on this graph that I could draw. In fact, that arrow indicates it keeps going forever and ever. So I can't list the x values. What we do is we write the domain in interval notation as an interval. And it's going to describe all of the possible x values. So what we're looking at when we're looking at a graph and telling what the domain is we're looking for the smallest x value that it could possibly be, and also the biggest x that it could possibly be. So to find the smallest x, all right, which is your minimum, it's going to be the leftmost on the graph, because all the smallest x values go to the left on a graph. X is the horizontal axis, and the smaller x values move to the left. So when we're talking about the leftmost point, this is our leftmost point. That point is as small as x can get on this function. And we look at what is the x value of that point. I know it's really hard to see. It's a little blurry. These lines are counting by 2's. So it goes 2, 4, 6, 8. This point is -8, comma, -2. For domain, we're only concerned with the x value. So what this is telling us is that -8 is the smallest value x can be. And we include it. So when we write interval notation, we use brackets to include -8. Then we look at the largest x, or the biggest, which is going to be the rightmost point on the graph. Now in this case, that arrow right here indicates that it keeps going up and to the right forever and ever. So when we're trying to find a rightmost point, we really can't. It keeps going forever and ever. So what we say is x can go up to infinity. The x values will continue to get bigger and bigger and bigger. We just can't see it, but that arrow tells us it goes up forever. So our highest x is infinity, and we always use a parenthesis around infinity. So that's how you do the x. Basically, what you're doing, this is telling you that our x values on this graph can go from -8 and on up. It's kind of like saying x can be anything bigger than or equal to -8. Now let's talk about range. Range is the y values. So it's similar, the process is similar, except when we talk about y values, we're looking vertical, up and down. So y values, since it's the vertical axis, when you're looking to see what the smallest y value it could possibly be is, you're looking for the lowest point on the graph. That's again this point. So the lowest point on the graph is that point. Again, it was -8, comma, -2, but for range, we're only concerned with the y value. The lowest y value on this graph is -2, and we use a bracket to include it. Now the highest y value, like with the x, the domain, it continues to go up forever and ever. That would be the highest y value, or the kind of maximum that y can be. In this case, we don't really have a stopping point. That arrow indicates it continues to go up forever. So our y value's highest point is infinity. This says that y can be anything greater than or equal to -2. It can go from -2 on up. So there are points on this graph from -2 on up for the y points. All right, let's practice a little bit. All right, here's another example of a function. We'll do domain and range for it. Remember, domain, we want the leftmost point and the rightmost point for the x. Leftmost point in this case, because these arrows indicate it keeps going up and to the left forever, leftmost point is -infinity. And we always use a parenthesis around infinity. The rightmost point, again, on this side, it continues to go up and to the right forever. So it will continue to go right forever, so our biggest is +infinity. So our domain is anything from -infinity to +infinity. It can be anything. That's what we're saying here, that the x values can be anything, because the graph will continue to go to the left forever and continue to go to the right forever. Now, range is going to be a bit different. It does have a stopping point. It's not anything. Range, which in this case is right here. That's the lowest point on the graph. And we're concerned with the y value of that. The point is at the y value, -8. I know it's hard to see. It counts by 2's. So the lowest point on the graph is -8, and we do include that. Now the highest point, that's how we find our biggest y value. Since the graph goes up forever, there's 2 arrows going up forever. It doesn't matter as long as there's 1 arrow pointing up. Then the y values will continue to get infinitely bigger. So our range goes up to infinity. This says y can be anything from -8 to infinity and up. Okay, let's look at this example now. This circle is going to have a stopping and a starting point for both the domain and the range. All right, domain, we're going to find the leftmost point on this circle. That's my graph. The circle is my graph. There's my leftmost point. The point that I just highlighted is -2, -4. For domain, we're concerned with the x value. The leftmost point is -2. That's my smallest x. Then we go and we look for the rightmost point. That point is right here. That point is 6, -4. Again, only concerned with the x values when we're talking about domain. My biggest x value is 6. And we use a bracket to include both of them. Okay, next we're going to talk about range. That's it for domain. Range, we need the lowest point, highest right here. That's my lowest point on this circle. The y value for that point, even though the point's to -8, the y value is -8. So -8 is the lowest the graph can go. It's the smallest y. The highest would be the biggest y. And that's right here. The point's 2, 0. So 0 is the highest y value. So in this case, what it's saying is my domain can be x, can be anything from -2 to 6. My range, or my y's, on this graph can be anything from -8 to 0. Okay, and let's just do a couple more practices. All right, domain here. Domain, leftmost, because of the arrow right here, it goes left forever. Smallest x is -infinity. Biggest x would be furthest to the right because of this arrow that points to the right and will go to the right forever. Domain is +infinity. This is another example of a domain that's all numbers, -infinity to +infinity. Range is going to be a little different. Range, we're looking for the lowest point and the highest point. It's important to keep the order. You have to start with the smallest. It's really tempting to start with this point up at the top. That's the biggest. That's the tallest or highest point. The lowest point, because of these arrows, both of them go down forever. My lowest point is -infinity. It continues to go down forever. This is my highest point. That point right there has a y value of 2. So my highest point is at y is 2. So I can go from -infinity to +2. That's a way of saying y could be anything less than or equal to 2. But 2 is like the highest point, biggest y can be. Okay, one last example. We're going to have a stopping and starting point for both domain and range here. Okay, domain, we're going to find the leftmost point. That's that one. The point there, it's supposed to be right there, is -6 comma -4. So the x value of the leftmost point on our graph is -6. Whoops. And because we see an open circle there, that's the time really we're going to use a parenthesis rather than around infinity. If you see an open circle, remember that open circle actually include that value. And that's what we use to show with a parenthesis. So anytime you see an open circle, you're going to use a parenthesis. All right, next we're going to find the rightmost point. That's this one right here. That point is 8 comma 4. For domain, we're only worried about the 8. That's a solid or filled in circle, so we use a bracket to include it. All right, range, we're going to look for lowest and highest point. So, lowest point, right here. That point has a y value of -4. It's -6, -4. We're going to use a parenthesis just like we did with the domain because it's an open circle. To represent that point, we use a parenthesis. Then we go with our highest point, which is this one right here. That point is 8 comma 4. We're using the y values for range. Highest y value is a +4, and we use a bracket. So our range, our y's can be anything from -4 to +4. And for domain, our x's can be anything from -6 to +8. And that's basically how you do domain and range of graphs of functions.